I've been trying to figure out when to use different search algorithms for SQLite. Typical things that I see people reach for these days is RAG. For the RAG sorts of things is using vector searching. But sometimes vector searching is a bit more overhead than what you actually need. So I'm just trying to get in my head what are the options out there. So I decided to just create a table of all the information. Obviously, AI's helped me with this. And we've got vector search, and we've got keyword search, and we've got LLM-generated search. And I've created a spider diagram just to go into this a bit more. I'm going to share this notebook, but I think this really highlights it. So if you look at the keyword search, which is the simplest, it's what a lot of people recommend these days, but it does have some shortcomings. So if you can see, it's the blue line here, so it's very easy to set up. It's very quick. But if you've got some spelling mistakes or it's in different language, then it's not going to be very good. So that's why it scores really bad on this spider diagram. But it's very easy to explain, and it's predictable, the answers, and it's very low cost. Once you've set it up, it's pretty much free. So the other one we've got vector search. So this is the one that a lot of people use. And vector search is very good, but the setup, we'll see in a bit in SQLite, it's a bit more difficult. It's not as tightly integrated. And then you've got the model to choose. You've got any further down processing to actually figure out as well, further down the RAG pipeline. So the vector would be good for the retrieval. How do you actually do the subsequent processes to that? And it could be the delay as well, because if you're using a cloud service for the actual vectors, then one, you have to use them for creating the embeddings, so the vectors, and then you'd have to use them for the opposing side. So if you've got a query to match it up to those. So it can be slow, or you can use some open source ones, which I've done here, which are quite lightweight. But using lightweight ones, you're not going to get good results unless you've done your own fine tune on the type of information. So the cost is going to be more than the keyword search. It's going to be very predictable because you're always going to get the same results based on the input. Setup, like I say, it's going to be a bit more difficult. Speed depends on how you're using it, whether you're using a local model or whether you're using a cloud service. You've got complications to set up then, depending on how you've got lots of options there. So that adds to this complexity, setup complexity. Spelling tolerance is very good because it's using the actual sort of phrasing. So it could be in English, it could be in French, it could be spelt wrong. There's so many things that it could actually work on there, which I quite like. But again, that depends on the model you use and how you fine tuned it, all that kind of stuff. And semantic understanding, so the meaning, so it scores the best on that. So yeah, it's quite a good solution. But again, you can't explain how it works. I think models, LLMs are still not very explainable, but it is very predictable. So then we have this other option, which I think is getting more traction, and I quite like it, mainly because it's so easy to set up and read. So this is the red line here. So it's LLM. So you're getting an LLM. So you're passing your query, and then the LLM will generate the SQL statement. And I think this is a lot easier to use and set up. So there's less friction in actually creating this. The speed, slow because you have to go to an LLM to sort of generate it first, but I think that could be offset if you're using something like Grok or Cerebrus, if I've pronounced that right. And also you could potentially use a local LLM. It depends how. I think the specialty ones for SQL, so you might be able to use something on there, so that could be a lot quicker. But again, you've got that complexity. So sometimes the benefit is just to use a cloud service and just get the best model to generate the SQL statement. Spelling, you can ask the LLM to generate alternative spellings for common spelling mistakes. So I think it can cover that one, depending on how you prompt it. Semantic understanding, yep, so same thing again, you can ask it to use semantic words to generate the SQL statements for the keyword searching. It's very explainable because it gives you the statement at the end, and you can present that to the user if you wanted to. Predictability, yeah, this one's where it is less predictable because depending on how the user's worded the query, you could get very different results, and the SQL statement has got a chance of generating an error or being misinterpreted. But for me, the simplicity is probably the best. If you've got millions of queries going through, then you probably wouldn't use this because it is quite high cost. But if you've only got a few queries going through, the simplicity of setup might outweigh the cost. So yeah, that's it. So we've got a table here, just it goes through that in different words. But that's my sort of a first approach. So let's have a quick look at how you can actually use vector embeddings and what options there are. So there's a couple of libraries. I chose this one after chatting with a LLM, just because it's the most out there. It's got 6,500. It's got sponsor, and it's also a license on it. Seemed a bit better. So this uses virtual tables. I'd probably actually give this one a go, but I've just run out of time. I just wanted to present what I've found so far. But yeah, no, it's a good option. So let's just get rid of that. Make that smaller. So I've imported some data just to test out the options out. This is some customer service data. I've actually got a real project that I'm doing this for, but I just wanted to figure out yeah, I just wanted to figure out what the option or what the best ways to do this was. So I just pulled in some data. So this is some fictitious data of some customer support tickets, and these are the answers. In hindsight, I should probably have selected something for dates because I think that would have tested the SQL generation because you could have done it between two dates. It gives you a bit more extra than just using a pure RAG option or vector search option. So let's have a look at the vector. So this is what you have to do to install the SQL to vec using sentence transformers. And then this is the simple sort of embedding that you have to do. So you select all the tickets that you want to do, or all the tickets or all the data, and then you add those to an embedding model, which is this model here, which is just a basic one that I just set up. It runs through and then it inserts those into the database. So an extra column next to it. So let's have a look at that column. So you can see this is the row, the body, and then this is where the embedding value is. So those two concatenated together equals this vector. So you notice here I've only done 2 columns, but in the database there are multiple columns here. So I think this is another area where the SQL statement will be beneficial because it can look across those columns, which we'll get into later. But anyway, that's the vector search. So if I want to search using that method, just use this simple function. But then I'd have to sort of incorporate it later to figure out how to display that information and how to integrate the other columns in there as well. So then we go on to the LLM generated. So these are libraries that I've imported. So I've rolled it all up into a function here. So this is the SQL database. This is the model that I'm using. You could use any model in there. And then the question. So the question is going to be what the query essentially. So what I've done is told the model that you're going to be an SQL generator for a support ticket. I've mentioned what the columns are, what the values are, or potential values are, and then I've just given it some action of what it's got to do, and then it's going to generate SQL statement and then run that through the SQL and then return the data. So here we go. There's no just a basic search there. So smart home tickets, and then this is the SQL statements generated. So you can see it's got smart home or smart home or smart home or smart automation. It's home automation. So it's got lots of different keywords for the different types. So if you've got different spellings in there, it's going to find things that are semantically the same. So you're kind of getting around some of the issues that you've got with a vector search. It's not going to be as accurate, but it's going to be a lot simpler to set up. And you could add extra things in there for common spelling mistakes and all that kind of stuff, and get the LLM to generate them because they're very good at that. And then smart token tickets is a high priority. That's going to run that through the SQL statement, and then priority high, and it knows that the high priority differences because it's in the statement there. So it gives you a lot more flexibility to generate an SQL statement if you've got some basic searching. So I'm edging more these days towards building something around this. I just think it's an easier way to do it. I've just got one function, the results, and I can just display that in a table or a chart. Whereas a vector, I've probably got some extra things that I need to do on top of that. Just to make sure I've got the right information, just because it's only taking into account a few of the columns here. Anyway, that's my thought. Just let me know what you think.